rows and columns in a form of XML, in a form of CSV, comma separated values. Okay, so that is in a structured data, right? Or in the form of JSON, a JavaScript object which has attribute and a value or a key value pair to store the data in the form of objects and arrays. So there we did talk about how we take the data as a structured data in different forms. Today our topic of discussions will be uh, preparation and analysis. Okay, we'll try to cover as much as possible of preparation. We cover preparation, but we try to cover as much as possible of analysis, and we'll continue with that. So the second stage in data analysis pipeline, that we see the four stages of data analysis pipeline, which is acquisition, then preparation, analysis, and presentation. So first stage we did discuss in our previous session. Now today we are discussing the second stage, which is preparation. Okay, and then we'll continue with analysis. So when we talk about data preparation, fine, we'll be thinking of preparing the data for analysis, which is for the next step in the data analysis pipeline. So what you see here, the steps, what you see here, we have acquisition, we took up and we discussed in the last session. Now we have a preparation. So why we do the preparation on the data which is acquired, okay, from the data source, is to make it ready for the next step, which is for the analysis. So we do prepare the data to do some analysis. Okay, so we'll see that how we're gonna prepare that data. There are a number of activities that you have to do here. Activities such as 3.5 using 3.1 notebook, 3.110 which is using 3.2 notebook, okay, 3.11 which is using 3.3 notebook, and 3.12 which is using 3.4 notebook. Okay, so these activities are very important, right? So you have to do these notebooks. These notebooks are important, like cleaning the data, selecting, projecting, sorting, and limiting, okay, using SQL, fine, and combining the data from multiple data sets and handling missing data. Okay, we will discuss this here in this session, but you have to do the notebooks for these four notebooks in this part 3, okay, which is very important for you. So data preparation, what is the purpose of data preparation? Okay, so in data preparation we convert the raw data set into a valid consistent data using structures and representations that makes the analysis straightforward. So what is a raw data first? A raw data is what data we get from the source, what we acquire from the source or from more than one source is a raw data. Okay, for example, I want to analyze the universities students data from more than one university. Okay, so let's say for example in Medina Munawwara I want to analyze the student data, fine, from more than one university. So I take the data from Taiba University, from the Arab Open University Medina branch. I'll take the data from Prince Migrin University. I take the data from other universities in Medina Munawwara, and then I put them. So these are the sources of data, and what data I get is the raw data. Fine. So which might be not clean, which might have some errors. Okay, some type mismatch. Fine. So that I need to prepare it. I need to prepare that data. Fine. So convert this raw data into a valid data, consistent data using structures and representation. Now, after converting the raw data into a valid data, into valid, consistent, using some structures like I put the data in the form of tables, okay, or I can put the data in the form of CSV file, okay, comma separated values, and that makes the analysis straightforward. By this, I can analyze the data directly. Okay, so the purpose here is that what we acquire the acquired data, convert that acquired raw data set into a valid, consistent data, okay, using structures and representation that makes the analysis straightforward. This is the purpose of data preparation. So what are the steps in data preparation is that explore the content, that is the data, its values, and the overall shape of the data. Okay. Then determine the purpose for which data will be used. Why you are exploring this or why you are preparing this. What is the purpose of using this data? Then determine the type and the aims of analysis to be applied on this data. Okay. These are three steps, initial steps in data preparation. First, you should explore the content, the values, and the shape of the data. Then, for what purpose you are using the data, you need to define, and what analysis you apply on this data, you need to define. Okay. Now, while you are exploring the data, you may discover some problems with the data, with the real data, or you can say with the raw data. So what is the problem I may discover? For example, I collect the data from the university, okay, from two different universities, from Taiba University and from Arab Open University. Now, when I am collecting this data, I may see some problems with the data. So what can be problems? For example, data is wrongly packaged. Okay, wrongly packaged in the sense they are arranged wrongly. Okay, data is not properly arranged. Some values may not make sense. Some values in the data, okay, what I collect has no semantics, no meanings. Okay, some values may be missing. Some data is missing. For example, date of birth of a student is missing. Okay, for example, contacts of the students are missing. Something like that. Format does not seem right. In that format, what I am collecting the data is not the right format, or what I get the data is not the right format. Data does not have the right structure for the tools and packages to be used with. So it's not in a proper format or a proper structure or in a proper uh, representation. Might be I am getting the data in XML form, but I want that in a table form. So data is not in a proper structure here. Okay, so these are some problems or the that can be discovered, okay, in the raw data. Fine. So while you're exploring the data, fine. So now to follow this, what we do in data preparation, we do a number of activities. Just 2 minutes, please. It's a prayer call here.
Hello. مرة قال دقيقتين وبيجي.
So a number of activities will be carried on here to in preparing the data. So in data preparation, we do these activities of data cleansing, okay, and data integration and data transformation. In data cleansing, we remove or repair the errors and inconsistencies in the data set. Okay, errors and the inconsistencies in the data set. Whereas in data integration, we combine the data sets. If we are having the data from more than one source, okay, so we will be combining the data. Fine, we will be combining the data. That is data integration, and then data transformation, which is shaping the data sets for visualization. You can say for some visualization, we'll be shaping the data set. So the same thing we call that in data warehousing, we use the term called extract, transform, and load for the similar activities. Okay, in data warehouse. Okay, fine. So here is a note. Some techniques are used in data preparation, especially in transformation and integration, also which are also used in to manipulate the data during analysis. That is, with techniques used in data transformation and data integration are also used in data analysis. Okay. Also, some techniques of analysis are used in data preparation. So we have techniques for preparation used in the analysis, and analysis techniques are used in the preparation. Okay, so we'll be looking here this here with some basic data cleansing issues that apply to a single and multiple tabular data sets and the process used to combine and shape them. Okay, so two things we'll be looking here. That is cleaning the data, which is a tabular data, the data in the form of tables, and then combining them and shaping them. Fine. So we'll be using techniques like, for example, selection, projection, aggregation, and joins for these. Okay. So to start with the first activity, which is data cleansing, or we can also call it as a data cleaning, is a process of detecting and correcting errors in a data set. If we have any errors, we'll see by examples what can be the errors in a data set. Okay, so it can even meaning removing the irrelevant part of the data is also data cleaning. Fine. Having found errors, incomplete and incorrect and inaccurate or irrelevant data, a decision must be made about how to handle these errors, like how to handle incomplete data, how to handle incorrect data, how to handle inaccurate data, how to handle irrelevant data. So there should be a decision on this, like how to handle these type of errors in the data. Fine. So it is all about detecting and correcting errors in a data set, which can be incomplete data, incorrect data, inaccurate data, irrelevant data, and we must have some decisions on this, how to handle these errors in the data. So first of all, from where these errors comes in the data, from where the error comes in the data. Error can be introduced in data in many ways. That is, it can be user input mistake. User has not entered the data properly. Okay, for example, user has to enter the name of the user or name of a student, but he has entered a name with the numbers. For example, Ahmad 123. Right? So this here it's not properly the name. Okay, there is a mistake here. User has to enter the salary in numbers, but user has entered the salary in words. For example, salary is $1,000. So instead of writing the numbers 1000, user has entered $1,000 in this fashion. So this is also a mistake from the user input, right? So first thing is that user makes some mistakes in entering the data, that is user input. Second thing, transport errors, that when we shift the data from one place, or when we take the data, okay, from the sources, during the when we take the data during this time, the data might be, got some errors, right? So there is a transport error. Conversion between the representation or disagreement about the meaning of data elements, right? Conversion between representation, how we are representing the data, right? For example, how we represent the date, okay, as day, month, and year, or we represent the date as month, day, and the year, okay, or we represent in letters, right? So this can be, some ways that errors can come in the data. Some error types can be incorrect formats, okay, incorrect structure, incorrect values in the data. Okay, so most operational system try to keep the dirty data out of the data store by doing this input validation. Input validation helps to avoid the data errors generated by user input mistake. When the user input the data, the input validation can be checked here to see that the user is entering the correct data, right? Also by database constraint. Database constraint allows data to be entered only in particular format or in particular range. For example, the age of a student has to be above 18. So whenever the user enter age less than 18, database will not allow to enter that value in the age field. That is database constraint. Also error checking. If there is any error while processing the data, fine. So that is also being checked in the database or in the by some program. So this are the, some steps to keep the erroneous data or the dirty data out of the database, out of the data store. Fine. This will help in reducing the errors in the data, in reducing the errors in the data. But still, we can find the errors in the data, and hence we need to do the cleaning task or a cleaning activity. The cleaning activity. Fine. Now here is an exercise, or we just try to understand that errors in the data. So identify the possible errors and the issues that may require further attention in this tabular data. This is a data of a person, or you can say the data of family members, where, just a second, please. Okay, so here we'll see in this tabular data, which is the data of family members, we'll see what are the possible errors that may need to handle. Okay, if you look at this data further in the slides, these are explained, right? The validity of the data, the accuracy of the data, the completeness of the data, consistency and uniformity of the data. So you check here, for example, if you look at the gender, you have MF, which is more understandable. M for male, F for female. But what is this R value, right? It's somewhere some invalid data is here. Okay. So even the postcode, if the postcode is not exist, for example, this postcode, let's say, does not exist in the list of postcodes, right? This also some invalid data. Okay. Similarly, we see there is no data here, no date of birth. Can a person have, exist without date of birth? So this is a null, or you can say some unknown value here. Okay. Here you say no postcode, fine. The approximate income, here you say nothing. Okay. And if you look at the first two rows, John Smith, J. Smith, their date of birth are same. Okay. Gender is same, postcode is same, but there is an inconsistency in the annual income or approximate income. Fine. So these are possible errors in this in this tabular data, which can be classified as valid, accuracy, completeness, consistency, and uniformity. Validity, for example, the gender, R is an invalid value here. Okay. So we need to handle this. We need to specify this, whether Smith J is male or female, or what should be mentioned here. Okay. Accuracy of the data. Are the data in this particular column are accurate? For example, let's say M69HP is not a postcode. Fine. In that case, the values are not accurate here. So there is an accuracy issue here. Completeness of the data. There is some incomplete data. Example here you see, and here you see, there's an incomplete data. Right? The data should be complete. Consistency. There is inconsistency in the approximate income of the person John Smith or J. Smith. Either these two be a different person. I mean, John and J. Smith are different. But if you see the data, it represents they are the same. Okay, but inconsistency over here in the income. Fine. Uniformity of the data. You see, for example, this date of birth and the income, both are not uniform. For example, date of birth showing here, and what is this date of birth? This is a date of birth in Hebrew calendar. Okay, but it's not in uniform. It's not in its uniformity. Fine. So it's not in the same like other data. Right. Similarly, here the currency is in euro and dollar. It's not in uniformity. Fine. So all these six things which we'll consider: validity of the data. We'll check whether the data is valid or invalid. Is there any invalid data or not? And we need to handle. We need to have some mechanism to handle this invalid data. Accuracy of the data. We need to check whether the data is accurate or not. If not accurate, then there should be some mechanism to handle that accuracy. Completeness of the data. Similarly, consistency. Similarly, uniformity of the data. All these need to be checked, and there should be some mechanism to handle these errors in the data. Okay. The next is integration of the data, that is combining data from multiple sources. That is, if you want to collect the data from more than one source, you collect them and you combine this data. So while you combine the data, again there is a chance that some errors may appear. For example, the consistency will not be the same, or you can say that there should be some there is some uniformity is not there in the data. Fine, because you are collecting the data from different sources. Okay. So harmonization is the data cleaning activity of creating common or canonical form of non-uniform data. Okay, it's called harmonization. I repeat, harmonization is a data cleansing activity of creating common, also called canonical form of for non-uniform data. Non-uniform data here, it means when you are combining data from multiple sources, they not have a uniformity. Okay, so mixed form or more often occur when two or more data sources are uses different base representation. Okay. So there will be uniformity may not exist if you are taking the data from different sources or you're combining the data which is taken from different sources. Okay. So for example, imagine a company with two departments. Now in one department they store the local phone numbers. The other department they store them these local phone numbers with the international format. So there is no uniformity between two departments how to store the phone numbers, whether to store it in a local form or to store it in an international format. Okay, you might have seen this while you're submitting the forms in different applications, while you are filling the forms in different applications. Some applications ask you to enter the phone numbers as if like 054 like this. Okay. Some applications ask you to enter the numbers in the form of 96654. Okay. So this is a different format, right? Fine. So if you combine these two, then there is an uniformity does not exist. Fine. So here there should be mechanism to handle this. Okay. Is another example of this. So, what is the approaches for handling this dirty data or the data with errors? So, we have few approaches here. Fix it. Fix it in the sense replace incorrect or missing value with the correct values. This is fixing it. Remove it. Remove it is remove the values or the group of values from the data set which has errors, fine, which are not uniform, for example, which are not valid, for example. Okay, or replace it. Replace with a default value or a marker for the incorrect values so that later processing can recognize it, dealing with within inappropriate values. And then the last step is approach is leave it. Why we leave it? Hoping that it does not have an impact on processing or the impact on processing is minimal. And then just leave it. Fine. So you can the approaches here can be adapted. Fine. Either fix it if it is needed by replacing the incorrect or the missing values with the correct values, or remove it, or replace it, or leave it if it does not have much impact on the processing. Fine. So these are the four approaches given here for handling the dirty data. So we also need to document the data cleansing process. Fine. It is very important that we document the data cleansing process. So what we document here is that how the dirty data was identified and handled, and for what reason it has been handled. Okay, this should be documented and maintain both the raw data, that is having the dirty data, and the clean data. Fine. So both forms of the data need to be maintained, the raw data as well as the clean data. Fine. If the data originally come from the operating system, it might be necessary to feed the finding back to the managers of these systems so that they can correct those mistakes in generating the data. Fine. So documenting is necessary here. Document the data. So documenting data cleansing process is required, where in documentation we'll keep what is the dirty data that was identified and how it is handled, and it will maintain both the raw data as well as the clean data. And also this document can be given to the operational system managers from where we take the data or the sources of the data. Now, what are the benefit of documenting data cleansing is that it allow others to consider the changes made and ensure they were both valid and sensible. So others can, you can share this cleaning process, the documents of the cleaning, so that others can have a look in this and see what changes has been made and what you consider the valid data. It will also help to build a core approach and method for kind of data sets that are frequently used. It allows managers of operating system where the data comes from to adjust and improve their validation process to avoid the dirty data or erroneous data in the coming future. It allows in time in time to develop effective cleaning regime for specialized data sets. So these are the benefits of documenting the data cleansing process. Okay. The next is data laundering and data obfuscating. So two more here, this is two more data cleaning activities. Data laundering attempt to break the link between the data set and its provenance, the valid provenance. Okay, so we are separating the data from its provenance, which is called data laundering. Okay, data obfuscating, also called data anonymization, is a process of removing the link between sensitive data and the real world entities to which it applies, while at the same time retaining the value and usefulness of the data. So you're just removing this with the real world entities to which this data is applied. Okay, so here in this data laundering and anonymization process, you're just breaking the links, okay, to anonymize the data, to anonymize the data, so that this data can be used anonymously in analysis purpose. Okay, the key difference between these activities and data cleansing is that in data cleansing we try to document and maintain full provenance of our data set. That is, in data cleansing we are just looking into the errors of the data, what is the errors in the data, right? And identifying those errors and handling those errors. Okay. And while in data laundering, what we are doing is that we are trying to lose its history. So we are breaking the link between the data sets and its provenance. That is, we want to lose the history from where this data is coming. We don't want to see that. Okay. And anonymization or obfuscation is that we are trying to produce anonymized but useful data. Okay, so these are the differences between these three activities: cleaning, laundering, and obfuscating. Data integration and transformation. Data integration was we said what we said is that combining data from different data sources, whereas data transformation is just reshaping the data. Fine. So a new data set may be in a wrong shape. For example, data might be held in a tree-like structure, fine, but we may need that in a table form. So we need to do a transformation. Okay. So another reason for reshaping data is to choose the subset of data for some purpose. So reshaping may also mean combining multiple data sets. It's not just reshaping the single set. We can combine multiple sets to generate one shape of the data. Okay. So we'll concentrate here on a tabular data in doing this integration and transformation. Right. To explore data integration transformation, we'll use some activities here. Okay. So from these activities, what we take here is that data, picking the data what we want. Okay. That is, we are taking the data that is what is required here for us. Okay, so in that case we do projection and selection. Projection is extracting columns from a table, and selection is choosing rows from the table. Okay, so any table, you see any table has rows and columns, has rows and columns. So in projection, what we do is that we take the columns. For example, if I say, yeah, okay, let's say this table. In this table, if I project the name and the genders, that is, I take only the names and gender from this people table, this is projection. I'm just selecting particular columns. Okay, this is projection. And selection is in this table, if I take, for example, data for Jane Smith and J Smith, okay, I take only these two rows data. Okay, so if I'm taking these two rows of the data, this is selection. Fine. In projection, I take only the columns of the tabular data. Fine. So this is applied when we are transforming the data into what we want. Okay, so with this one you have the activity as well as you have the notebook to do this. Fine. Then sorting the data. Sorting the data is required here. Okay, in transformation, sorting is required to understand it more better. For example, if you look at these two tables of sales, which table will give you a quick view or a quick understanding of what is there in the table? I mean, in this table, from this table, what we get. So of course, the table one has unsorted data. That is, first it shows April, the total amount, January total amount, May total amount, and so on. Fine. We don't see that here. We see that it is in an unsorted format, but we don't see any. We can see that, for example, uh, any of the analysis we cannot make properly here. So in table one, we just see what we see. If there is some, months and the sales, the amount of the sales. Okay, but we don't make any judgment out of this. But if you see the sales data, which is sorted in months, okay, so we see that January has this amount and of sales, February has this amount of sales, and so on. But if you look at the sales, we see that the sales are decreasing every month. So we can do some analysis here, saying that every month as it goes, the sales is decreasing. The sales is decreasing. So with the help of sorting, we can analyze this and we can get to this that, okay, there is a decrease in the sales after every month. Okay. Whereas the same thing is put in an unsorted format, then there is no such analysis can be made directly here. Fine. So this is the use of sorting. Fine. The other uses are exist. So sorting is an important in transforming the data. While we transform the data, we also worry about how it will be sorted. Okay, sorting can be done in terms of numbers. For example, 0 to 10, 9, for example, in an ascending or descending order, or sorting can be done in terms of on strings. Okay, like to arrange the numbers from let's say from A to Z. Oh, sorry, the arrange the letters from A to Z. Okay, or sorting can be done in terms of days of a week. So first come the Sunday, then Monday, then Tuesday, or months of a year. First comes Jan, then February, then March, then April, and May, and so on. Right? So sorting can be done in many different ways. Okay. So sorting of strings or characters, it based on the ASCII values. Is based on the ASCII values. Fine. So if you put the sortings on strings or characters, that will be based on the ASCII values. And if you put the sorting in numbers, that will be in the format of numbers. Okay. Fine. Limiting the display of the result data. Okay, so for example, if you have a very large tables of the data and you don't want to look at the very large, but you just want to look at few rows from this table, then you can limit the display of the result. right? So the tools like Python or SQL, the technologies like these will help you in limiting the results and displaying the results. Fine. So it will be more easy for you if you have a limited set of data that can be analyzed easily in compared to you have large set of the data and getting difficult to analyze. Okay. Combining data from multiple data sets, that is the data integration. Okay, so we see that the analysts often call for having need more data for analysis purpose. So here the meaning of more is what? We need more data. So what is the meaning of more here? More, it means they want more tables or they want bigger data sets. Okay, what does more here means? So more can be in different forms. Okay, there are several interpretations of more. More the same, more of the same, that is a bigger data set with a more data elements, that is a longer table, one with more rows. Okay, so for example, I have data of 10 students. More here, it means no, I want data of 100 students. So it is the same data. For example, I have a student data, which is student ID, student name, student mobile number, student age or date of birth, and student address. Okay, so student courses. Fine. So this is the data I have. I have this for 10 students. So here, if the analyst says I want more data, one interpretation is that it means he needs more students data. That is not just 10 students, he needs 100 student, 500 student data, or 1000 student data. That is one thing, one meaning of more here. Okay. So another meaning is that more data about data elements we already have. That is, we need more columns. That is, for example, I have that student data, student ID, name, mobile number, address, okay, and courses. But I want more of this, more than this. I want his father name, I want his birthplace, I want his passport number, I want his ID number, Ikama number, okay, all this. So that's another more here. So this more will just adding more columns to the table. We'll go on adding more columns to the table. So more data. Another meaning is that more data sets, that is more tables. I want more tables from different sources. I have the student data of Arab Open University. I want more data set. That is, I want more. I want from another university same student data. I want from another college same student data. Fine. So these are different interpretations of what we call more data. It can be more data in the sense more data about the more objects or more elements, data elements, or it can be more columns, okay, or it can be more tables. Fine. So we get more and more data, we combine them. Fine, we combine it. Okay. Now, while we combine it, we may get that missing data or invalid data. Fine, or we can say that erroneous data. Fine. So now coping with missing or invalid data elements. If there is anything missing or invalid, we'll just how we can cope with it or how we handle it. Fine. There should be some mechanism to handle it so that you have a correct data. Fine. So for example, date of birth is missing here. In this case, date of birth is missing. So date of birth, of course, every person will have a date of birth, but might be this is not known at this point of time. So what you can do here, you can just write not known, or you can write null. So what you can write here, that is the main thing. Okay. Now, also, for example, this gender R, or you can say, for example, sorry, the missing data is here. Postcode is missing, approximate income is missing. Okay, income might be, for example, postcode might be does not exist because might be that place does not have a postcode. Okay, income missing. This might be the person does not want to disclose what is the income. Okay, so here you can say missing the data. Fine. So missing of the data can be for a number of reasons. Okay, that we need to identify. In SQL, there is a null marker. There is a null marker. So null is a marker that is telling that there is something is missing here. There is telling that something is missing. Okay. For data processing purpose, simply marking missing data may not be sufficient. So it might be more useful in doing something such as categorizing the reasons of missing data. Right. So, for example, we can mark it as not known or mark it as when we all arrive. But here we say that when we all arrive is not a format of style, and not known is not a format of number. Okay, so there can be, like, for example, invalid data here. There can be invalid data. Fine. So we need to find some flags, some matches. Like, for example, we can use not a number, NaN now. Great.
السلام عليكم دكتور.
عليكم السلام.
شو دكتور ما عندي شاشة يعني. ما
سوري.
طالع. أقول السكرين ما هو طالع عندي.
الآن
لا نفسه يمكن أطلع وأدخل.
طيب خلاص، ظاهر للطلاب آخر، فممكن أنت بس تطلع وادخل مرة ثانية إن شاء الله.
يمكن بطلع.
طيب. Okay. Fine. So we can mention these flags like not a number, not a time. Similarly, we can mention a flag as null. So null may be representing here the missing value. Okay. So null is a marker in a place of missing value in SQL. So null can be used here in any place where the values might be missing. Fine. None is also a marker here. So for example, you can see here the colors here, none. Fine. So none can be a marker here showing that no color has been mentioned here. Fine. So it's not a name of a color. Okay. So, but how do we consider this? Whether we consider this as a name of a color or it is as a marker. Fine. So we should have an agreement that none is not a color, and it means that there is no color mentioned here. Okay. So how do we treat these values? Fine. So treating the missing value or the invalid data. For example, we say that okay, we use the null flagging the invalid values. We use the flags like not a number or null. Okay, but how do we treat them if there is a missing value? For example, the Jane Smith's salary is 0. Can we consider this as 0? No, we cannot consider this as 0. If we consider this as 0, then it may mislead us in, for example, the sum of all incomes or the average of all income may mislead this. So we need to ignore this part. Okay. So with the help of null marker, we can just ignore this part in, for example, in summing up all the incomes or in calculating an average of all the incomes. Okay. So if you use those markers, for example, here total amount, if I want to calculate here, for example, the sum of all the amount, where there is a null will be ignored, for example, and then we calculate only the sum of these 33, 57, 54, and 20. Okay, which is 74, 77, 107. Okay, so null is not considered. Even we calculate the average of this will be calculated only for these three values, and null is not being considered. Fine, as a flag, as a marker, null will not be considered. Fine. Also, for example, here if you take or talk about this none, we should have an agreement that none is not a color, and none means that no color has been mentioned. And so none is a flag to mention no color and not as in color. Okay. Similarly, the same for NaN and NaT. Okay. So we should have an agreement on this, but the agreement can be of different. Okay, so it's not necessary that every analyst or everyone who is preparing in this the data sets does not agree to the same point. Okay, so no consistent or automatic way to handle the full range of semantic interpretation of missing values, the meaning of these missing values. Okay, so you have to treat them with care. You have to take care that how do you interpret the missing values. Okay, whether you consider them in calculations, in analysis, or you replace those values with some default values and then you consider in analysis or not. Okay, or you discard them. So treat them with care, decide what they represent, how they can be interpreted, and how they can be best cleaned so that the subsequent processing analysis does not lead to logical errors. Okay, this has to be decided at the time of data preparation. At the time of data preparation. Fine. So in data preparation, till now what we are discussing is all about the data that has an errors and how we can handle the data. So data comes from the data source, fine, comes as a raw data that may have some errors. Okay, so this raw data will be put into some activities, some processing of preparing the data, and most of is that how do we handle that invalid data, inconsistent data, incomplete data. Fine. So the data that has an errors, okay, how do we handle them? Okay, that has to be decided here. Okay, so this is all what we have here in preparation of the data. So we took the data here as what? As a tabular form. We took the data here in a tabular form and we prepare the data, the tabular data step, which is for the analysis purpose. Okay, so this is all what we have here for you in this part 3 of data preparation. So there are some exercises here that you can go through. These exercises again explaining those problems in the data. For example, here this is a tabular data, identifying the errors in this data and what need to be done with these errors. Okay, so for example, names are problematic here, mixed representations used here in date of birth. Okay, and similarly, the gender R is something invalid, missing date of birth. Okay, monthly income format is not there, date format is not proper. Right, this is an exercise here. We also have an exercise about cleaning the data. Fine. We have some activities here for you. These activities are related with the notebooks of part 3. So you have to do these activities along with the notebooks of part 3, right? So it's very important for you to do these activities. Okay, these activities will be helping you in dealing with this dirty data, the technique for dealing with the dirty data, right? Look at this taxonomy of dirty data for dealing with dirty data, right? Dirty data, for example, can be in a form of missing data. Okay, so in missing data where there is no null not allowed constraint. No null not allowed constraint. So there is missing data, and whenever there is a missing data, then the null is allowed there. So null is marked. Missing data where null not allowed constraint should be enforced. So when there is a missing data and null is not used, then how do you deal with that data? Okay, that's important thing. Then not missing but wrong data is also a dirty data. One is missing data, fine, another is not missing data. Not missing, but it is a wrong data due to some errors. For example, the input from the user is wrong. Okay, so no enforcement of integrity constraints. Constraints are not enforced. Like for example, name should be characters. Okay, this is a constraint. All the names of students should be in characters, but someone is entering with numbers. Okay, that is okay, not implementing the constraint or enforcing the constraints. Fine. Integrity constraint supported in relational database is use a specific constraint, use of wrong data type, for example, dangling data. Dangling data, it is that about data which is is not been identified. Duplicate data not enforcing the uniqueness integrity constraint. Okay, so this is all the dirty data, and there should be way for handling these dirty data. Fine. So there are notebooks that you have to do this with this handling or preparation of the data. Fine. So this is what we have here for you in part 3. If you have any questions with regards to the preparation of data, please. Any questions in regards to preparation of the data?
No.
Yes, if you allow me, Mr. Muhammad.
Yes, Mr. Umar.
Yes, Habib. A very quick one. Actually, I'm asking you regarding this application. Is there any guidelines? Because this is actually, to me, the first session I attend. So is there any actually guidelines how to install the application to do the exercises?
Yes, it is there. There is a short video in the CLMS from where you can download this virtual machine, as well as that you can watch that short video which is clearly explaining how to download, how to install, and how to work with the notebooks.
Will do. Thank you.
You must work. Yes, another one. Any other questions with regards to part 3 data preparation?
There is another question, if you allow me, and I'm sorry,
Yes.
I'm repeating myself, but
No
not
problem.
actually related to the application, how to install. It's about now if I have two set of data, it means 2 sheets. Let's say 2 sheets. Now,
Okay.
what is the ideal approach to do the data cleansing of each of these 2 based on the 6 actually categories, and then combine them, or combine them and do the data cleansing?
See, it depends on what you want to do. As we saw in the beginning of, the start of this preparation, we saw that it's not just cleaning process. After cleaning, we also see that what is the purpose of this data. So let's say that, for example, you have 2 data sheets, as you mentioned, and now if you look at these 2 data sheets, whether these 2 data sheets are coming from the similar source or from different sources. Okay. So if it is from the similar source, there is a most chance that this data will be in a similar format. Okay, there will not be the uniformity will exist in the data. Fine. So in that case, you can think of like just let go to combining this data and then look for cleansing this data. And if it is not coming from the same source, then you have two options. One is that do the cleansing, but apply the same rules of cleansing this data on both the data sheets, and then combine it and then recheck again for cleansing. Or you combine them and you have a set of rules for that. How do you represent and how do you define this data? What is the meanings of this data or the semantics of the data? And then you do the cleansing process.
Thank you. It's clear now. Thank you.
So we don't, fix any one approach here, but rather we'll try to keep it open wherever and how this data will be used. Okay, that is the main thing. The purpose of the data should be in front of us so that we can apply this process.
Yeah, but one of the most important thing, which is always there is a very high, I would say, the headings that say don't touch the raw data. Always try to make a copy and do whatever you want to do.
Yeah, that's what it is. We mentioned in the slide where we were discussing about documenting the data, documenting the cleansing process, is that keep the raw data and the clean data. Okay, meaning that definitely you make the copy of it.
So the source and target.
Yeah, the source, the what you acquired from the as a raw data should be kept as it is, and then generate that clean data.
Fair enough. Thank you, sir.
You're welcome. Okay, let me put this recording and stop here. So we'll have this session 2 recording in separate. Sorry, part 3 recording in separate. I will record it again with part 4, inshallah. Okay, so let's have a break for just like 5 minutes and then we'll continue with part 4. Right?